All right, let's do 3 quick problems, real quick, not fast. They're tricks. They're tricks. So we're going to use these identities. Sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared. Knowing that tangent is sine over cosine, cotangent is cosine over sine. 1 over sine is cosecant, 1 over cosine is secant. So let's see some problems. So maybe we get this. Tangent of 20 degrees minus sine of 20 degrees over cosine of 20 degrees. And I told you, we're starting off nice and mellow. We don't know anything about 20 degrees. You get something like 87 degrees, you're like, it's a trick. I have to use an identity. It's probably going to turn out to be 0, 1, or negative 1. So our first step is we're like, well, that shit's in tangents, and that's sine's in Wait. Sine over cosine is equal to tangent? So let's write this down. Tangent of 20 degrees minus, and then let's rewrite this. Sine of 20 degrees over cosine of 20 degrees is tangent of 20 degrees. Now I don't need to know anything about tangent. Same picture minus same picture has got to be equal to 0, right? Right. Okay, let's deal with another one. 3 quick problems. We've had to deal with 2 long videos. Let's make this one quicker. Let's go with this. Sine squared of pi over 12 plus 1 over secant squared of pi over 12. I said pi over 12, wrote pi over 4. Oh my goodness. So the angles are the same. So wait a second. Wait. 1 over secant? What's 1 over secant? Oh, it's not written here. Oh, it's the same thing. 1 over secant is the same thing as cosine. These mean the same thing. They're just written funky. Well, what's also true is 1 over secant squared is the same thing as cosine squared. Oh, did I write 1 squared up there? Oh, shoot. Now, we only have one frickin' identity that we could use with sines, cosines. Sine squared plus cosine squared is equal to 1. So we take a step more like, okay, cool. Sine squared of pi over 12. And then we can replace our 1 over secant squared with cosine squared of the same gosh darn angle. And now we have sine squared plus cosine squared of the same angle, which is equal to 1. All right, now I'm going to get tricky with you. I'm going to get tricky with you. I'm going to get tricky with you. I'm not really going to get that tricky. Okay, I lied. I'm totally going to get tricky. I want to show you one of the toughest problems we have. Tangent of 200 degrees times cotangent of 20 degrees. What do you think the answer is? You had to guess. I don't know anything about these. So I want to draw this real fast. Like, this is the tough one. You're going to have 1 in your homework, and I get 200 degrees. And this is 180. So do you know the reference angle? Do you know the reference angle of 200 degrees? It's 20, isn't it? And ASTC, isn't tangent positive in the third quadrant? So I'm pretty sure that tangent of 200 degrees is the same exact thing as tangent of 20 degrees. They have the same reference angle. And where 20 degrees over here, it'd be positive. All of them are positive, tangent's positive. So tangent of 20 is the same thing as tangent of 200. Told you this one's a tricky one. So we could actually rewrite this, and instead of tangent of 200, we write in tangent of 20 times cotangent of 20 degrees. And now we can use the identity. The cotangent of 20 degrees is the exact same thing as 1 over tangent of 20. And it equals 1. So there was a shorter one with some of the tricks. Sometimes we've got to use our sine squared plus cosine squared is equal to 1. Sometimes we've got to use the fact that sine over cosine is tangent. There's lots of different tricks, and this is going to help us to understand what the frick is up. So I think that's about it for this section. No, we got a couple more. I got to play a couple more games with you. And then once we have these couple of games done, we'll be done with this section. You shouldn't have this many videos in any prior section or future section. These are the longest. All of them will be shorter, so sorry for so many videos, but there is so much to learn at the beginning. All right. See you in the next.